to my new calculus channel. My name is John Gabriel. Today I want to measure once and for all what is the difference between a ratio and a number. So let's begin. Now, in order to understand measuring, one has to understand what is a number. And in mainstream mathematics, there is a very blurry distinction at most between ratio and number. Neither have ever been well defined or understood. So a ratio is literally a comparison of two homogeneous sizes or magnitude. As you see here, this illustration here shows you three ratios. The first ratio has a red line which is equal to the black line. The red line comes before the colon and the black line after the colon. The red line is called the antecedent because it is that magnitude which is being measured, and the black line is called the consequent, which is used to measure the antecedent or red line. So if we measure this particular ratio, we get the number 1. Right? If we measure this particular ratio, we get the number 2, and likewise this particular ratio, we get the number 3. Now, in the diagram above, the red, blue, and black lines are all of equal length. And so it's very easy to find the measures. So we call 1 the measure, of this first ratio. Why? Because the black consequent fits into the antecedent exactly. This black consequent fits into the antecedent exactly. Or it measures the antecedent exactly, or it divides the antecedent exactly without remainder. And the same can be said for this ratio, which is called 2, for this ratio whose measure is called 2, and for this ratio whose measure is called 3, or given the name 3. So the measure of all these ratios is 1, 2, and 3 respectively, right? So the numbers 1, 2, and 3 are measures of the ratios, and they're shorthand for these numbers: 1 over 1, 2 over 1, and 3 over 1. Okay, and these are the actual names, but because we always measure in terms of the abstract unit, we just talk about 1, 2, and 3. So supposing we want one of two equal parts of the unit, that's actually a half. But in geometry, it is very easy to divide the unit into any number of equal parts. However, this is not the case in algebra. If the ratio antecedent, as you see here, this red line, is smaller than the consequent, which consists of the black and green line, all these lines are of equal length, right? So in algebra, we only deal with multiples of the same size. So we have to give these parts names in the measure, right? In this measure here. And so how do we find a ratio whose measure will be equal to 1 to 2? And the answer is that we create a new unit using the same black consequent. So the new unit is this consequent here. And we specify one of two equal parts just by putting one red line on this side. Okay? And so we can write that this is the ratio represented by 1 to 2, and its measure is 1 over 2. So in the diagram above, the new unit is the consequent, indicated by the black and green line segments, both of the same length. Right? So this is the consequent. And then we don't actually perform any kind of division in algebra when the antecedent part of a ratio, that is less than its consequent, is being measured. The gist is that we can form any number using the same consequent length, which is the black segment, with which we started out. Now you need to stop and think about all these things. I'll place a link to this article so that you can print it out and read it. Now, a fraction is in fact the measure of a given ratio. Okay, given any P and Q magnitudes, whether they be line segments, masses, areas, weights, whatever, both multiples of the same consequent, right, the same consequent magnitude, the ratio P to Q has a measure P over Q in algebra. So in effect, all that happens is that the name P is placed on top of the vinculum. The vinculum is a horizontal line here, okay? And Q is placed on the bottom of the vinculum, as you see here, to form the fraction name representing the measure P over Q. Therefore, no actual process of division or repeated subtraction takes place. That is, P over Q does not mean P divided by Q, okay? And it has never meant that. If, however, P is greater than Q, then we can perform what's called long division or obelisk division, which is repeated subtraction, okay? And it's only possible if P is greater than Q. So this is an additional process that enumerates the number of units in a given fraction, okay? As we saw back up here, we enumerate one equal part of this unit by just placing one red line, right? Okay, and so, for example, the ratio 20 to 3 has a measure 20 over 3, but since 20 is greater than 3, we can perform obelisk division, or also known as long division, to further refine the number in terms of units and or a remainder. That is, 20 over 3 is equal to 6 units and 2/3, okay? And that's pretty much what is the difference between a ratio and a number. So to conclude, a ratio P to Q is a comparison of two magnitudes, P and Q, separated by a colon. And a number P over Q is the measure of this ratio. So in geometry, a measure is possible always using the same unit. In algebra, we have to find a new unit that is made up of equal parts of the given initial unit we started using, as I've shown you throughout this video. And then we state the numerator in terms of these equal parts. Okay, in other words, we enumerate how many of the equal parts we're talking about and give it a name in terms of the fraction parts, P and Q. I hope you've learned something now finally about the difference between ratio and number, and that you will study this article. And I'll chat to you once again in the near future. My name is John Gabriel, and this is New Calculus Channel. Till next time, goodbye.